And we're back. While I was waiting for the last video to render, I went ahead and took my vectors, wrote them down, and they are orthogonal as we have seen. And now we are going to do one more step. We're going to normalize them, make them be length 1. So we remember that to make a unit vector, we take our vector, non-zero vector, I should say, and divide by his length. And so we would then get that Q1, our final step here is 2 over square root of 5, 1 over square root of 5, and 0. Q2, which is the V2 vector divided by, or multiplied by 1 over his length, turns out to be negative 1 over square root of 5, 2 over square root of 5, and 0. And Q3 happens to be V3 over his magnitude, but V3 was already just the K vector, so he's already length 1, so we're already pretty good. And that actually kind of makes a lot of sense, because if you notice, Q1 vector and Q2 vector live in the XY plane, and they are orthogonal to each other. And so what's orthogonal to things in the XY plane? Things in the Z-axis direction. So we now have created vectors Q1, Q2, and Q3. I'm going to come over here and write that again, 0, 0, 1. So these purple vectors, the Q1, Q2, and Q3, are our orthonormal set. And they're even, in fact, a basis, an orthonormal basis. Okay. So just a quick summary here. We started out with our non-orthogonal, non-length 1 vectors. We went to an intermediate step. We made vectors V that were all orthogonal. And then I did the last step of normalizing them. And so we did the orthonormal. So we went from U to V to Q so we could finally get the orthonormal set. Now, just for full disclosure here, I could have done the normalization here, and instead of using V1, I could have used Q1, but that's going to introduce some square roots that if I can avoid, I will. Now, another thing that we could do here is when we saw this step at V2, negative 3/5, 6/5, and 0, since we're going to normalize length 1 later on anyway, I could, if I wanted to, factor out the 3/5 or negative 3/5, depending on how we want to do that, and get the vector 1, 2, 0. And since we're going to just do a scalar multiple of him later, I could have just used, whoops, that should have been a negative 1, 2, 0. I could have just used this down in the next step as my V2 vector, because I'm going to make him be length 1 later on anyway. And then that will save me some fractions. So you can do it that way. All right. So now that we've got our orthonormal set of vectors, what I want to do is remember our original U1, U2, and U3 vectors. Let's see if we can get this all on the same page. Whoop, there we go. And we're going to remember that Q1 is 2 over the square root of 5, 1 over the square root of 5, and 0. Q2 was negative 1 over square root of 5, 2 over square root of 5, and 0. And Q3 was 0, 0, 1. And we remember our U1, U2, and U3 vectors. What I want to do now is make a new matrix R that is composed of the elements where we inner product Q1 with U in the proper order here. So I remember it as Q comes before U in the alphabet, and U always follows Q when we have it in the English language. And notice the 1, 1, this is the 1, 1 position. Uh-oh, this is supposed to be the 1, 2. Uh-oh, typo for Pedrero. And 1, 3 position. Q2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3 positions. Okay. So I'm going to pause the video while you do the inner products of these guys, all possible pairs here. Okay. So we'll put our pause sheet up. All right, so now that you've made the R matrix, hopefully you got the same thing I did: square root of 5, negative 1 over root 5, 3 over root 5, 0, 3 over root 5, 1 over root 5, 0, 0, 1. And hopefully you notice something special about this R matrix. He is upper triangular. Okay. And let's go ahead and make our Q matrix, where the Q's are the columns. So we've got 2 over square root of 5, 1 over square root of 5, and 0 as the first column. Negative 1 over square root of 5, 2 over square root of 5, and 0 as the second column, and 0, 0, 1. So here was our Q matrix. Let's take our R matrix, because we're going to multiply Q times R here in just a second. So we've got square root of 5, negative 1 over square root of 5, and 3 over square root of 5. 0, 3 over square root of 5, 1 over square root of 5, and 0, 0, 1. So let's do the Q matrix times the R matrix. Let's multiply that. We'll do a few terms together, but then I'll let you finish up. So we'll get 2 square roots of 5 over square root of 5, which is 2, plus 0 plus 0. So our first entry here is going to be 2. Let's do the 1, 2 position. So we'll do the first row of the first matrix times the second column of the second matrix. We'll get negative 2 fifths minus 3 fifths, and negative 2 fifths minus 3 fifths, plus 0, of course, is going to be negative 1. And let's do we'll finish off this first row. We've got 6 fifths minus 1 fifth plus 0. 6 fifths minus 1 fifth plus 0 is 1. So I'm going to pause the video and let you finish the matrix multiplication here and see if you notice anything cool. Okay. All right, so what did you get? I got 2, negative 1, 1, 1, 1, 1, and 0, 0, 1. But if you're careful, notice that this is just the U1, U2, and U3 vectors. Okay? Or in other words, if I were to make an A matrix out of the U1, U2, and U3 vectors, I've just created a way to break that A matrix down into a special Q matrix where the columns are orthonormal times an R matrix, which is an upper triangular. And so when we do Q times the R, where we've defined R always this way, we will get our original A matrix, which is our vectors in as columns. In this case, we had 3 vectors, so I'll write them down. Cool. So taking a matrix, turning the column vectors, or the columns of the matrix, into orthonormal columns, orthonormal vectors, and then creating this R matrix right here is something we call the QR decomposition, and you will use that in your numerical methods classes. So next up, I want you to try another problem here. I've tweaked things just a little bit. So let me give you the vectors negative 2, 0, 1, or sorry, negative 1, 1, 2, 3, and 1, 1, 1. So I want you to find an orthonormal basis Q1, Q2, and Q3 based on these vectors in that order. So start with U1, turn him into V1, then make V2, and then make V3. And then do the QR decomposition of this matrix by creating the R matrix, which remember that the R matrix, once I fix my little typos, is given by this guy. Okay. And to let you double check yourself, I've given you the answers here. Here's the Q matrix, and here's the R matrix as well. So that way you can double check yourself. We'll see you in the next section.